Okay, so today we're going to be learning how to describe functions. So we did a really good job earlier this week about identifying functions and determining whether or not they were functions. And so today we're going to describe functions. And so the essential question is, what are some characteristics you can use to describe functions? So what's really cool about functions is actually we use a lot of the same vocabulary that we use when we're talking about linear equations. So for example, you should know that if a function is linear, then it's going to make a line, because that's that key word in there is line inside of linear. It's a fat line. But basically, if it's linear, it's going to make a line. If it's non-linear, it can still be a function as long as it passes the vertical line test. So that's where we might have something that looks like a U. So that's still a function. It's just not linear, but it does pass the vertical line test, obviously with a thinner line. My line is super fat. So we'll make that not so fat today. All right. Now, not proportional is something also that we are familiar with from linear equations. Remember, proportional relationships just go through the origin. So that would be an example of a proportional relationship. A non-proportional linear relationship it's still going to be a line. It's just not going to go through the origin. So, for example, this would be an example of a non-proportional relationship because it doesn't go through the origin or the center. So really what we're going to be doing is we're going to determine if a function is linear or not. And the best way to do that is to look at it. Because if you graph a function and it's linear, it's going to form a line. But if you graph a function and it doesn't form a line, then it's not linear. So those are really easy ways to kind of identify whether or not it's going to be a linear function or not a linear function. So our first example is talking about the temperature at dawn, and it's saying that it was 8 degrees Fahrenheit and increased steadily 2 degrees Fahrenheit every hour. It's given to us by the equation y equals 2x plus 8. So I'm going to highlight that because that's important. I should probably highlight the 8 too. Ooh. And it gives the temperature y. So y represents temperature after x hours. So we're going to state whether the relationship between the time and the temperature is proportional or non-proportional. So we know it's linear. We just need to determine if it's proportional or non-proportional. So if you're really big brain, you could already kind of determine whether it's proportional or non-proportional because we know proportional relationships have a certain equation. So if you remember that, I'm very proud of you. But we're going to test to see if it's proportional or non-proportional. And how we do that is by creating an input-output table. So I just choose 0, 1, 2. And I'm only choosing positive values because it doesn't make sense to go back in time, right? So I'm just choosing 0, 1, 2. And I'm going to use the equation to figure out what the y is. Because remember, the equation is y equals 2x plus 8. So how I do that is I just go here. And wherever I see an x, I'm going to replace it with the x value I have. So instead of writing 2x plus 8, I'm going to write 2 times 0 plus 8. Okay. And then if I do that math, 2 times 0 is 0. 0 plus 8 is 8. So y equals 8. So then now I have an x value and a y value. So I'm going to write my ordered pair. And I'm going to put this in red because this is what I'm graphing. So my ordered pair is the point 0, 8. Again, 0 came from the x value that I chose. And 8 is what the equation equals when I plug in 0 for x. So I'm going to do the same thing with 1. So exact same steps. I'm going to replace the x in the equation with 1. So instead of writing 2 times x plus 8, I'm going to write 2 times 1 plus 8. 2 times 1 is 2, and 2 plus 8 is 10. So I get 10. So now I have my ordered pair when x equals 1, y equals 10. So I'm going to write that as a point, 1, 10. All right, last one, I'm going to have 2 times, I'm just replacing x with 2. So 2 times 2 plus 8. So if you can see, all of our numbers, like all of our equation, our setup right here is the same. The only thing that's changing is the number in the parentheses. So what I used to do is I actually just went ahead and did this part first and then did the math. And that's something you're welcome to do too. So 2 times 2 is 4. 4 plus 8 is 12. And so this is, we know it's a linear relationship because it's increasing by 2 each time. So that kind of makes it easy. So then I'm going to write my ordered pair. 2 12 is my third point that I'm going to graph. Now, if you look, we have to graph it now. So if you look, I did not give us enough room to graph any of these points. So what we're going to do is we're going to change these a little bit. We're going to count by different numbers. So instead of I'm going to count by twos, basically. So this is going to be 2, 4, 6, 8, 10, and 12. Okay. So instead of counting by ones, we're going to count by two. So I'm just going to kind of like make a note by writing it to the left of it. So instead of 1, this is actually 2. Instead of 2, this is actually going to be 4. Just that way I can actually graph all the points. So because I was silly and did not give us enough room. Instead of 3, we're going to have 6. Instead of 4, we're going to have 8. Oops. Instead of 5, we're going to have 10. And our x values are okay actually on here because we're counting by ones on our x's. It's so the y values that are not okay. And then instead of 6, we're going to have 12. All right, so now we'll actually be able to graph it. And then I'm just going to cross out these numbers so we don't have to even look at them anymore. I don't want those numbers. Those are dumb numbers. Okay, so basically, again, we're counting by twos now instead of ones. So let's go ahead and graph these points. So the first point I have to graph is 0, 8. And 0, 8 is right here because remember, we replaced 4 with 8. We're counting by twos now. The next point I have is 1, 10, which is right here. And then I got 2, 12. So the question is just asking, is it proportional or non-proportional? Of course, draw your line through it. And I can assume it's going to go this way too. So is it proportional or non-proportional? Well, remember, it's proportional if it goes through the origin and non-proportional if it doesn't. Well, this graph definitely doesn't go through the origin, so it's non-proportional. And what's nice is like once you graph it, you can see that, oh yeah, it's not proportional because look, it doesn't go through the center. So non-proportional. And I want you to add the note, it doesn't go through the center because that's what's going to help it kind of stick into your brain. It doesn't mean anything if you just say no, right? It doesn't go through the center. Okay. So that's how we determine whether a linear relationship is proportional or non-proportional. We take the equation and we just graph it. So in the second example, we're told that a square tile has a side length of x inches. In the equation, y equals x squared gives the area of the tile in square inches. So remember, area is length times width. Well, both sides are x, then x times x is x squared. So we need to determine whether the relationship between x and y is linear. And if it is linear, is it proportional? So this one was linear because it made a line. So we need to see if this is going to be linear. So we're going to do the same thing. We're going to create an input-output table. We're going to create points, and then we're going to graph those points. And we're going to try to determine if it's linear, if it's proportional, all that good stuff. So I'm again just went 0, 1, 2, 3 because it doesn't make sense to have a negative side length, right? I don't even know what that would look like. So let's go ahead and do some math. So 0 squared, and write that 0 squared. Well, 0 squared is 0 times 0. 0 times 0 is 0. So my first point is just going to be the point 0, 0. So when x equals 0, guess what? Y equals 0. All right, let's check out what 1 squared would be. So again, the equation is x squared, y equals x squared. So I'm going to do 1 squared. Remember, when we're squaring a number, we're not multiplying by 2, we're multiplying by itself 2 times. So 1 times 1 is 1. So then the point I'm going to graph is the point 1, 1. Now you might think there's a pattern, but it isn't what you think it is. So let's just keep going. Let's calculate 2. So remember, again, we're looking at 2 squared. So 2 times 2 is 4. So then now I'm going to graph the point 2, 4. Good job. All right, and then the last one I want to try is 3. So I need to figure out what 3 squared is. Again, remember, this isn't 3 times 2. It's 3 times itself 2 times.
3 times.
So 3 times 3 is, what's 3 times 3?
3 times.
9.
9.
Yep, it's 9. So 3 times 3 is 9. So then now I'm graphing the point 3, 9. All right, so now I have my points to graph. I need to try to determine if this is going to be a linear relationship, and if it is linear, is it proportional? So let's go ahead and start graphing these points. So I know one's at 0, 0. And then I have another one at 1, 1. And then I got 2, 4. So over to 2, up to 4, and then 3, 9. And 9's not on here, but if I did put 9, probably would be somewhere around right here. So if I connect these dots, you should be able to see that it's not a linear relationship. It's got a curve. It's what we call a quadratic relationship. And so this is a function, but it's not linear because it doesn't form a line. And since it's not linear, I don't really care if it's proportional or not because it doesn't matter. So this is going to be a nonlinear relationship because it doesn't form a line.
Mommy, I need to pick.
So hopefully you find this easy. It's really, I mean, and again, if you're struggling with the math part of it, like the calculations, you can always use that really awesome Desmos calculator. But it's taking everything we've learned and really kind of putting it into a simple format.